Hey, Geometry, Mr. Florio. This is Unit 5, Lesson 11, Prisms Practice. The goal of this lesson is really just to practice using the formulas that we've learned so far in this unit. And then in here, we'll also see some situations where in order to find the height of a given solid, maybe we have to use trigonometry or the Pythagorean theorem. And if so, so be it. But in order to do that, you need a right triangle. So if you don't have a right triangle, sometimes you just need to draw one in. And then work from there. So the warm-up 11.1 new heights, calculate the height of each solid, round your answer to the nearest tenth if needed. So we're just trying to find the height of these. So the first one, I just want to find the height, which would be the distance from the top with a perpendicular line down to the base. So that's what we're trying to find. And I guess here I'm recognizing that I know the base of this triangle is 6.5 and the hypotenuse is 17.3. So this right here forms a right triangle, and we could just use Pythagorean theorem to find h. So a squared plus b squared equals the hypotenuse squared. And then use the calculator. 6.5 squared, I think, is 42.25. And 17.3 squared is 299.29. So if we subtract the 42.25 on both sides, then the h squared has to be 257.04. So if h squared is that, then we just take the square root of both sides. And I'm going to get that h, that's about 16. So the height is about 16 for this cone right here. For part B, we need to find the height. And remember, the height's from the top of this perpendicular down to the base. So I need to find the distance from the top straight down. So whatever that would look like, I need to go straight down. I'm going to draw it right here. So it's got to go straight down to the base. And we need to make a 90-degree angle with the base. So that would be the height of this shape right here. That's what I'm trying to find. I know this slant length is 12. And I know this angle is 50. I think I could use SOHCAHTOA here because I have a side length and an angle. From this angle's perspective, we know that the side that I'm looking for is the opposite leg. The side I know, the 12, is the hypotenuse. So if I was going to use SOHCAHTOA here, that's an H. Which one uses opposite hypotenuse? That's the sine. So we're going to use sine of 50 is the ratio of the opposite leg and the hypotenuse. Now I want to solve this for h. I'm just going to multiply both sides by 12. So those divide out. And so whatever 12 times the sine of 50 degrees is h. And if I put that in the calculator, I get about 9.2. So anyways, so the point here is, even though they don't tell us that h is 16 or 9.2, we have enough information to figure that out. And sometimes drawing a line helps us see the right triangle, and then we can use either trigonometry or Pythagorean theorem.